Okay, so we've talked about scatter plots and estimating a line of best fit quite a bit. So we're going to talk about residuals now. So the definition of a residual is that it is the y value on the point minus the y value on the line. So I'll show you a couple examples. So the first point happens right here at x equals 2. So for x equals 2, the y value on the point, let's see, there's the point. So this would be the y value on the point, 2, 4, 6, 7, minus the y value on the line, right about here. What is that going to be, like maybe 8.2 or 8.3? Okay, and then when I subtract 7 minus 8.2, I get negative 1.2. Okay, so that's called the residual. And when I make a residual plot, the x value is still 2, but now I plot the negative 1.2. So something like this. For x equals 2, the residual is negative 1.2. So somewhere negative 1, slightly below. Okay, so let me show you another one. I'll turn it into a different color. So let's look at, let's see, the next point on the scatter plot happens when x equals 3. So the residual is going to be the y value of the point. Okay, so that's right there. What was that? That was like 8. Yeah, the y value of the point is 8 minus the y value of the line right about there. What is that, like 7.6 maybe? We're estimating, right? So your answers will not be exactly the same as my answers. So 7.6, and that's 0.4. So for x equals 3, I plot this 0.4. So slightly, well, that's probably higher than 0.4, but you get the idea, right? Okay, so let's do one more that way, and then I'll show you a different way. Okay, so for x equals 4, I've got 2 points, so let's do this one with the equation. So let's specify the low point for x equals 4. The y value of the point is right here, and that is what again? 2, 4, 6. It's always the y value of the point minus the y value of the line. Okay, minus at x equals 4, the y value of the line, gosh, that looks pretty stinking close to 7. Maybe it's 6.9. Okay, it's not quite at 7. So 6.9. And that would equal negative 0.9. So for x equals 4, I've got a negative 0.9, so almost down to negative 1. Okay, now notice, for this first point, it was below the line and the residual was negative. For this next point, the point was above the line and the residual was positive. And then for this next point, the point is below the line and the residual is negative. So to summarize that, if the point is below the line, that means the residual is negative. And if the point is above the line, that means the residual is positive. Okay. Now, so using that, we can actually do this in a different way. I know this one's going to have a positive residual because it's above. Can you see that? Yes, you can. It's going to have a positive residual because it's above. And then all I have to do is estimate how far away that is. So counting up from here to here, looks like it's about one full box plus another half of a box maybe. So that residual would be 1.5. So still for x equals 4, right? I have a 1.5. So there's actually 2 residuals because there's 2 points. Okay, so let's look at x equals 5. This point is going to have a negative residual because it's below. And I want to estimate. Okay, let's see. That looks like maybe this little segment right there, maybe like 0.3. And then this little segment right there, maybe like 0.5 or 0.6. So that would make like 0.9. So the residual, since it's below, the residual is going to be negative 0.9. Okay, so for x equals 5, I'm going to go negative 0.9 again, almost down. Okay, let me go back to my thinner marker so it's a little easier to see, and then we'll finish this. Okay, so you can do this for every single one of them if that's easier for you. Or shortcut, remember that positive means, above, sorry, let me do that again. Above the line means positive residual and below the line means negative residual. So for x equals 6, I'm above, so I'm going to be positive, and that looks like about 0.2 to me, and that looks like about 1, and that looks like about 0.5. So 0.2 plus 1 plus 0.5 is 1.5, so 1.5 around there. This one, it's below, so it's going to be negative. That's pretty small. Maybe that's 0.1. Maybe it's 0.2. Again, we're estimating, so we're going to get different answers. That looks to like 0.6 to me, so I'm going to say it's 0.1 plus 0.6, which would make it 0.7, but it's below, so it's negative. And then I've got this guy that just looks like it's about half a unit above the y-axis. And it's above, so that makes it a positive. So positive 0.5, not negative 0.5. And then this guy is 0, right? That is on the line. So the distance from the line is 0. There's nothing for, what is this? 7, 8. There's nothing for x equals 9, but for x equals 10, the residual value is 0. Okay? So the residual plot tells us if a line is a good model. Okay, if the residual plot is scattered, then a line is a good model. So this looks fairly scattered to me. What we're looking for is if there's some kind of really clear pattern in the residual plot, then a line is not a good model. Then a line is not, oops, sorry. If there's a clear pattern in the residual plot, then a line is not a good model. So I'm going to give you a second to copy that because I know it wasn't showing on the screen. So for your homework tonight, I'm grabbing the workbook page. You did page 165 last night, and you're going to take these two scatter plots and you're going to make residual plots for them. So the first thing would be to estimate a line of best fit and then do what we just did. Actually, it doesn't make sense to do it with that one because that one's got a straight line. So all the residuals would be 0. So you're gonna, for number 5, you're gonna make a scatter plot. And so if you wrote on this page on Monday night, then just take a picture of this graph or copy the graph down really fast before you, oh, you're not turning it in, it's Tuesday. So you'll have this page. And then also with, let's do, those are really big. Let's do this data. So you're going to make a scatter plot, and then you're going to draw a line of best fit, and then you're going to make a residual plot. So this is page 163. So you might actually have to take a picture of this because I'm pretty sure those are in your folders. So let's get this to pause and then take a picture of that. Okay. So you're going to make 2 scatter plots and then use those scatter plots to make residual plots, just like we did in these notes. So scatter plot first, calculate the distance between. below the line is a negative residual, above the line is a positive residual, or just use this equation and then you don't have to remember that, as long as you remember point minus line. And then create a scatter plot and discuss if a line is a good model or not. If it's fairly scattered, then a line is a good model. If there's a clear pattern, then a line is not a good model.